Hello everyone, we are the students of SVCE. I'm Arham and my friend Soumya are here to do a project on Cisco Packet Tracer for computer networks, which is our subject. Here we provide a step-by-step guide on how we are going to do this project for college purpose. What we are going to do today is we are making Cisco Packet Tracer for step-by-step guide for you 4 different networks with IP addresses and connect them using routers. End devices. Each network will have 2 PCs for 4 networks. We need 8 devices. The switches. Here we add 4 switches, 1 for each network. We assign meaningful labels to each PC. There is given PC1, PC2, PC3 and PC4. We add 4 switches, 1 per network. We assign names to the switches: switch A, switch B, switch C and switch D for clarity. Then we add routers. We add 4 routers, each serving a network, and we name them accordingly: router A, router B, router C and router D. Routers will handle inter-network communication as switches alone and cannot manage networks with unique IP addresses. Connections. We use copper straight through cables to establish connection PC to switch. We connect each PC to its respective network switch. Switch to router. Use fast Ethernet port, each port to connect to its respective switch. Now we add serial ports to routers. The routers require serial ports for interconnecting with other routers. By default, most routers have limited ports, so the additional ports need to be added. Access physical configuration. Open the router's configuration and the interface, then we navigate. Power down. Turn off the router. Prerequisite hardware changes. Add serial interface. Insert WIC2T module into an empty slot to provide 2 additional serial ports. Then we restart the router. Check the connection how we have done for 4 networks. Here we connect router A to router B to C and router C to router D. Then revert back router D to router A. We do this to reduce optional redundancy. Assign one router as DCE to check. Then we provide with IP addresses for all network A, B, C and D. Here it is done, as you can see. And then configure the routers. Assign IP addresses to fast Ethernet serial interfaces. Configure static or dynamic routing. Then testing is done. Ping for PCs in one network and to PCs in other network. Troubleshooting using tools like traceroute and checking interface status. Here, this is how it's done, as you can see.
Hi everyone, this is Soumya. Continuing where Arham left off, I would like to move on to assigning IP addresses to each network. Assign unique IP addresses for each network. For like end users, use 0.2 and 0.3 as host IDs and 0.1 as the gateway. And for serial connections, we assign unique IPs for inter-router communication. For example, we set 192.168.1.2 for PC1 and the gateway for PC1 is 192.168.1.1. Also, the serial connection is 11.0.0.1. Next, we move on to configuration in routers. Assign IP addresses to router interfaces, such as Ethernet interfaces and serial interfaces. For Ethernet interfaces, use Class C IPs, such as 192.168.1.1, and for serial interfaces use class A IPs such as 11.0.0.1. Now enable interfaces, turn them on to activate the connection. Next, maintain the structural IP plan for consistency and easy troubleshooting. Next, we have routing. Configure static routes for intercommunication and define the destination network subnet mask and next hop router ID. For example, for 192.168.2.0 network, the next hop from router 1 is 11.0.0.3, and ensure routes are defined for all networks in every router to enable seamless communication. Next, we move on to testing connections, like test by sending messages or using the ping command between the PCs. For example, ping 192.168.2.2 from 192.168.1 from a 0.1.2 network. The first ping may take longer due to ARP resolution. Anyway, moving on to troubleshooting, if communication fails, verify if our IP configurations on PCs and routers, and correct routing table entries in the routers, or activate connections such as green status indicators. Conclusion of this presentation can be like data flow seamless and between PCs across networks and demonstrating a full functional setup with static routing. This ensures reliable communication in multi-network environments. We know the video is not aligned properly, but it's just for college purpose and nobody's gonna hear it in a detailed manner anyway. So yeah, that's it. After setting up the static routes, we successfully established seamless communication between all the PCs across different networks. As you saw, the data flows smoothly through the configured routers, ensuring reliable and efficient connectivity in this multi-network environment. This demonstrates how static routers works effectively to manage communication between separate networks. Yeah, thank you for watching the video and don't forget to like.